All right, can you folks all hear me okay? So I haven't, there's no problem for folks to work on this week. I have uh, on the discussion board because we have the exam. And so I have problems from chapter 26 next week. And the homework will be due on October 1st. So most likely not too many people started on the assignment because we started the chapter. So I just have a couple of conceptual questions to ask, and then I can answer any questions you may have. So I can do a poll. Again, I can do this as a poll. So just give me a moment here to set this up. Okay. So let me set up the poll, and I have a question already showing on the screen. I will change the view in a second. So take a look at the slide that you see, and you're given that circuit of capacitors. And let's say A and B would be hooked up to a power supply. The question is, if all the capacitors are the same, what is the equivalent capacitance between A and B? That's the question. So I'll give you a moment to think about it. And while you're thinking about it, I'm going to draw a picture on the board. That's circuit. Okay, so everybody answered that one pretty quickly. So I'm going to end the poll, and I'm going to show you the results. So you all see the results, right? Yes?
Yes.
Okay, good. All right, so let's go through this problem. Let me change the view. Okay, so I've drawn on the board the problem. So all the capacitors have the same value. So when you look at these two capacitors, how are they connected? This one and this one after the other. Yeah, they're connected in series. And then these two are connected in series also. So if these two are connected in series, of course the equation for series is given by that, and I can just dot, dot, dot. Okay. So if they're both the same, We have 1 over C plus 1 over C is 2 over C, then you take the reciprocal to C over 2. So I can replace those two and these two. And these are in parallel. And in parallel they add. And so yeah, most of you guys got it correct. C over 2 to C over 2 is C. So yeah, the equivalent capacitance was C. So let's try another one. Almost the same circuit. It's this one. Let me change the view. And let me relaunch the poll. And so this time, that's my circuit. Now what? It's always good as you do these kind of problems to draw a picture on a piece of paper and try to reduce the circuit to 1. That helps a lot. Just trying to answer the question in your head, that's kind of tough. I would have a hard time doing that. All right, so everybody's answered. So I'm going to end the poll and show you what you've chosen. So we have a nice distribution of choices here. Okay. Very nice distribution of choices. So let's go through this one. All right, so let me stop sharing. So I guess the first question is, when I connect these 2 points together, basically what I've done is I put a wire between these 2 points. This point and this point are essentially at the same potential because I connect them together. It's a conductor, right? So this point and this point are going to be the same V. You're going to have one voltage here, a different voltage here, which is the same as that here, then you find voltage here. If you had it hooked up to a battery. Of course, if you were charging this, you'd have charge splitting these 2 directions. And these 2 are connected together at the same voltage. So really I can redraw that in the following manner. These 2, how are they connected? Aren't they connected in parallel? These 2 are connected in parallel, and then these 2 are connected in parallel. If I take these 2, remember this wire might look confusing, but I could, if I want to, do this. The same thing. The current splits here, then comes together here, splits here, and comes together. So these 2 are in parallel. I can replace those 2 with a single one by adding them. These two, I can combine them together into a single one. Those two are in series, so guess what happens? 1/2 plus 1/2 is 1. The reciprocal of 1 is 1. And so total capacitance is C. So again, the answer is C. Does that explanation make sense? Are we okay with that one? Okay, I got one more. This one's going to be a little more challenging. This one. You might have to do some work on this. So I have 3 capacitors. You have C1 in parallel with the combination of C2 and C3. C1 is 1 microfarad, C2 is 2 microfarad, and C3 is 3 microfarads. And you want to know which capacitor has the greatest charge on it. I will say this, you should be able to eliminate 2 choices right off the bat. Maybe I shouldn't have given that hint. Yeah, if it were me, I might have to. Maybe not. You might have to do math. You might have to solve the problem. So as you're thinking about that, let me redraw. Let me redraw the circuit on the board. I have one more person who needs to decide. Okay, so everybody's chosen. Let me end the poll. Let me share the results. There you see the results. So, let's think about the answer to this question. Let me stop the sharing. And that was my last question, so I'm done with the poll. one of the things I told you off the bat, I can eliminate 2 answers right off the bat. Why is that? Can anybody tell me why I can eliminate 2 answers? Anybody want to? Yeah, C2 and C3 have the same charge. So B and C are gone. Okay. So B and C are gone. So it's got to be either A or D. Okay, so that's the first thing. Eliminate those 2 choices. Okay. So the next thing is, I know that if this is 10 volts, the voltage across this one is also 10 volts. Why? Because it's in parallel. What about here? What do I do? Well, the voltage across here is 10 volts. Now, the charge on this one is going to be 10 microfarads, right? Because C1 is 1 microfarad. Remember, Q is C delta V. So if the effective capacitance of this system is bigger than 1, then the charge on these 2 is going to be bigger than the charge on this, which is 10 microcoulomb. Okay. Right. This is 2 microfarads, 3 microfarads. So the Q for these 2 is going to be C effective times 10 volts. Is this C effective bigger than 1 microfarad? All right, so I do, and then you can do 1/2 plus 1/3 minus 1. Common denominator is 6. This combination has a higher capacitance, it's going to have more charge. Both of these are going to have the same charge on them in series. So the answer is D. Does that make sense? Does anybody have another way to look at it or anything? Of course, now you know Q, because the Q on each one of these is going to be 10 volts times 6/5 microfarads. I'm not 10 volts, sorry. The charge on each one is 10 times 6/5, whatever that comes up to be, 12.5 microcoulombs. And then you can figure out the voltage on each one. 12 microcoulombs, sorry. This will have 4 volts across it, this will have 6 volts across it. Do you have any questions on what I covered today in lecture? I didn't have any good questions on actually calculating capacitance, because most of the ones I actually looked these problems up on WebAssign, and the conceptual ones were based on the questions I asked in class, so those were kind of useless for us, I guess. Oh, how did I get to 46 volt? Good question. I did that quick, didn't I? So you're okay with the fact that both of these are 12 microcoulomb of the charge. If I solve for delta V, it's Q over C. So 12 over 2 is 6, and for this one, 12 over 3 is 4. Okay. Yeah, I did that one a little quick. Are there questions? Okay. Yeah, like I said, today is a short meeting because we just started the material. So next week, then what I expect is that you have questions on homework on chapter 26. There's some challenging ones and there's some straightforward ones. Typically, the circuit ones are pretty straightforward. The ones that are more challenging are the ones where you're calculating capacities. So there's a couple of challenging ones in that, but then I think that the circuit ones should be straightforward. No, there's no problems, no presentations this week because of the exam. So when you look, and I'll probably send an email reminder. You look on the discussion board, you'll see the ones for next week, for chapter 26. So what'll happen is there'll be problem for chapter 26 next week, and then the week after I'll have 27 and 28. Because I've already done chapter 27. Okay. So the week after will be 27 and 28. Are we okay then, folks? Okay. And you guys all uploaded your videos? I know some people still having problems. Don't worry if it takes a long time to upload. Just upload it. Okay. All right. I guess we'll end it here then. All right. Take care. You two have a good weekend.